In this video, you will learn the fundamentals of machine learning through practical agriculture and environmental science examples, even if you are a complete beginner. My name is Meshak. I'm a data scientist researching the application of machine learning in agriculture and environmental science. So, what is machine learning? Machine learning is the science of enabling computers to learn patterns from environmental or agricultural data, and that can also be any other type of data. But I'm fitting this into this context because we are focusing on environmental issues and agricultural problems. So, and make predictions or decisions without being explicitly programmed. So, take for example, we have a regular logic like if rainfall is less than 300, then yield is low. So, that can be the standard logic. But there's a lot of missing information here that we can't write so much logic to make predictions. And that is where machine learning comes in. So, instead of writing this kind of logic, we can have machine learning model that learns from historical data of what has happened on that cropland before based on the rainfall, the temperature, the fertilizer, the crop yield, and every other information that is available. And that can then make prediction of what is the crop yield at this specific time. Now, machine learning has been categorized into many forms, but here in this video, I try to simplify it into what I feel can be easily understood. So let's look at the big picture, which is machine learning. The first category is the learning style. The second category here is the model type, and the third is the application area. And for the learning style, we see an example, which is supervised learning. Another example for the learning style is unsupervised learning, and the third is semi-supervised learning and reinforcement learning. So moving forward in this video, I'll be explaining each of these learning style to make it clear. Then for the model type, we have the traditional ML and the deep learning. So the traditional ML are example, you have the linear regression, the tree-based model like the XGBoost, the CatBoost, the light gradient boosting machine, the random forest, and several others. But the deep learning are the kind of machine learning algorithms that works with neural network. So we are going to see that further in the rest of the video. For application area, we have natural language processing, we have computer visions, we have speech, we have time series, and we have combined. So when we talk about machine learning, it is not just about doing one thing specifically. It can be a combination of many models. It can be a combination of different applications, different learning style, and all this can come together to build a standard system that can serve the purpose you designed it for. Supervised learning, as an example of the learning style, it is when the dataset contains the input features and the known output. So look at this. You have precipitation as a variable, which is the input to your model. You have the second input, which is the soil type, and you can use that to predict crop yield or crop type. That is supervised learning. You know what the input is previously, and you know what the output is previously. And this can then be given to the model to learn the interactions between the input and the output and give you something or a model that can then make prediction given a specific input type. But supervised learning can be categorized into two mainly. You have like the regression, and the regression is used when the output is a continuous variable. I will see an example here. So you have your input, precipitation, you have your soil type, and you have the values. Then the output is something like crop yield, which is a continuous number. So that's why you have 2,500, 5,000.75. So they are not discrete. So you cannot categorize the output when training the model. That is an example of a regression problem when you are using supervised learning. And the example is you have predicting crop yield in tons per hectare or kilogram, relating it to the previous example shown in the table. Then you can estimate soil moisture percentage, you can forecast nitrogen leaching, and you can predict greenhouse gas emissions like N2O or CO2. They are in continuous numbers, and that is why they fit into regression types of a type of supervised learning. And the common regression model, you have linear regression, ridge and lasso regression, random forest regression, and gradient boosting regression. So each of these regression model will be building projects in the future on this channel around them, and we'll be digging deep into individual model. So watch out for the video that will be coming up after this video. So remember to subscribe and turn on the notification bell to see when I make this upload, and you can benefit from that. The second subtype when it comes to supervised learning is the classification. Now, classification is used when the output belongs to distinct categories, simply the opposite of the regression. So here you have your input and output, and what you are predicting here in the output, you have, for example, maize, cassava, rice, tomato. So you can see these are categories of crops or types of crops. So that's what you are doing in classification. Classification is simply classifying the output into, of course, specific number of classes that you've defined while training your model. And here you can see examples of classification problems or classification type of supervised learning. You have the crop disease detection, where you can then classify a specific kind of crop into healthy versus infected. Then you have land cover classification, where you can classify a specific region into forest, cropland, water, or urban areas, or what they call built up. So given a specific remote sensing image like Sentinel-2 or Landsat image, you can make classification. Then the other one is drought risk classification, where you can classify drought into low, medium, or a high. Then soil fertility classification, where you can classify soils into poor, moderate, rich. This is very important because as a farmer or as an agriculturalist or an environmentalist, it is important to have this information so that you can design your cropping plan, your environmental management plan, and all other kind of plans that you want to make. And common classification models, you have logistic regression, you have decision trees, you have random forest classifiers, you have support vector machines. And there are many others, but these are just the few that are listed here. Then the other class that we have for learning style is the unsupervised learning. And what happens with unsupervised learning is that you can discover hidden patterns in data. So this works with unlabeled data. So compared to the supervised learning, where we have the labeled data, here we have the unlabeled data. You have your input, and based on this input, you want to classify them or cluster them into how similar they are based on the input. So here, you don't have any output that you give while training the model, you only have the input. So let's say I have this precipitation and I have this soil type, and I want this to cluster them together to see where in my region or in my data do I have similar precipitation and soil type, and I can categorize them into one class. So by doing that, the model will then be able to make prediction on what are those classifications. So you have 0, 1, 2, 3, and this could mean anything depending on the goal you want to achieve. And an example of this unsupervised learning is the clustering. So you can cluster groups or areas or samples with similar characteristics together. So for example, you have this raw data, and the model can then look into this raw data and then cluster them into their similar space. So look at this example now. So this is the model, and you can see now that it has been able to separate them. So things that look like each other are clustered into the same group. So you can see here you have a different kind of fruit, another kind of fruit, and another kind of fruit. And this has been clustered to make it clear for you. So the example, you have grouping farms based on climate and soil similarity. So let's say you want to plant and you want to see how your land area, how are they divided? So you want to see where the climate and soil they are similar. Then you have the agroecological zoning, where you can know if this place is the savanna, this place is the arid region, given specific data set that you give to it. Then you can identify regions with similar rainfall patterns. You can group crop response patterns and do a lot of other things that you want to do. And the common classification models, you have the K-means clustering, the hierarchical clustering, and you have the DB scan. And there might be also other kind of models that you can use. The second type of unsupervised learning is dimensionality reduction. And all this do is simplifying complex environmental data. And look at an example. You have this data set that has up to 50 variables. So you have x1, x2, x3, up to x50. And training a machine learning model, this might be too high in terms of the dimension. This might be so much variable, and some of them might be redundant, and as they don't have special information that the model needs to learn from. So training your machine learning model on this much number of variable may not really help or make any difference, and that will make your model very heavy in terms of size and implementation and all. So as a data scientist, you want to look at what is the most compact or the most optimized way to build a model that will be lightweight and still achieve its purpose. So this is where dimensionality reduction comes in. So you can apply a dimensionality reduction model, and that will help you reduce the dimension into the three most important variables, or four or five, depending on what you want. So you can see here now we've gone from these 50 variables into just these three variables. So the model learns the whole data and try to see, okay, what can I combine together that makes sense, that will really give important information to this modeling process. So that is how dimensionality reduction work. And for dimensionality reduction, you have an example of reducing noise in the data, improving visualization, so to be able to see your data clearly. You can use it to speed up model, like I said the other time. And an example is reducing dozens of soil properties into a few key factors. So your soil property, you can have the soil texture, for example, the clay, silt, the sand, and several others. You can have the water feed spot space, you can have the feed capacity, and several other soil properties. But maybe all the soil property don't have so much information to give differently. So you can feed this soil data into a dimensionality reduction model, and it's going to return the main ones that will really help the model learn. So it will look at the whole data set and try to summarize them into few number of variables that will give you exactly the same kind of output that the long or the high dimension data is given to you. So common techniques, we have the principal components analysis and we have the autoencoders. In future videos, we'll be working on projects that will require using these techniques in for different problems, especially in agriculture and environmental science. So watch out for that. The other category in the learning style, we have the semi-supervised learning. And semi-supervised learning is useful when labeling the data is expensive. So look at this. You have your previous information where you have the precipitation and soil type. You know the crop yield in some parts, but you don't know the crop yield in other parts. And you want the model to learn. So you use semi-supervised learning where some part of the data they are labeled and some part of the data they are not labeled. So it is like supervised and unsupervised together in the same data set. An example is when you have few labeled soil samples but many unlabeled ones, or you have limited field observations with abundant satellite data. So that is what you do with semi-supervised learning. So the model learns from both labeled and unlabeled data. And the fourth, which is the last on the learning style, is the reinforcement learning. And what happens with reinforcement learning is learning through interaction with the environment. And this works through trial and error using rewards. So it is like a baby that is trying to walk or try to climb the stairs. So the baby will try to take some steps and the baby may fall and the baby will rise again and try to take the step in a different way until the baby is able to gain his or her balance. That is the same thing that happens with reinforcement learning. That's what they use to train robots to do different tasks. So we see how it works. So you have the agent, and the agent could be like a model that is trying to take a specific action. And you have the environment, and the environment is the space where the agent is working in. And you have the state, which is what is the current situation right now in that environment. And the action is what the agent decides to do to the environment, and you have the reward. So this is how it works. So the agent will look at the state and say, okay, this is the state of the environment and I need to do something about the state. So it learns what is the current situation, and the agent will take an action, and that action will have an impact on the environment. Then, looking at the impact, the reward will be measured, and the reward will be that, okay, the action on this environment, what impact does it have on the environment? And that will be calculated as a reward, and the reward is to inform the agent if that action is something good that should be repeated or something that should not be repeated. So then the environment will update its state based on the action of the agent on the environment. So the state will be updated, and then the agent will get the reward back. And the reward could be that the environment improved or the environment was destroyed given the action on the environment. So we see something that makes it clear now. So number one is you have the agent, it observes the state. Let's say it is a farmland. The agent observes the state of the farmland and the state is a dry soil. Then the agent takes an action, and the action is that it waters the field at a specific amount or it carries out irrigation on the field. Then, taking that action, the environment changes. So, the change on the environment is that the soil becomes wet. And when the soil becomes wet, you have a reward. And the reward is that the plant grows healthier. So when the plant grows healthier, then the agent now learns from that to see, okay, based on this action, it has a positive impact on the environment. And the agent will update his strategy to then repeat that successful action in the future. So let's say the reward is negative and the plant does not grow healthier. Let's say the plant is redundant or the plant dies. The agent will update his strategy so that such strategy is not repeated again in the future. So that is how reinforcement learning works. So now to deep learning. So deep learning is simply the model learning complex patterns from large scale data. So a lot of time we use deep learning for big data because it has capacity to learn complex pattern when you give it a lot of data set. So when your data is really small, you may not really need deep learning for that. You may go for the traditional machine learning algorithms. So it is a subset of machine learning that uses neural network with many layers. And we can see an example. So you can see the network input, and the network input is like the input data that you are given to it. So you have the input layer, and you have the hidden layers that learns the features. So it learns from the input, and then learn that feature and adjust or kind of does an internal engineering of the feature and feeds it forward into a specific output layer. So each of this is a layer, this is a layer, and the output is also a layer. And each of this is a neuron, is a neuron, is a neuron, a neuron, a neuron, a neuron. Each of the circle that you're seeing, and they are doing something to the data to be able to give a specific output. So depending on how complex your process is, you might increase this hidden layer. So this hidden layer, this is just a single hidden layer. You can have more layers in your data. So sometimes you can have as much as 64, 80 layers and all, depending on the complexity of the problem you're solving. So this is feed forward. So this is fed forward into the output. And when it's fed forward into the output, you will have a process that checks if whatever is predicted in the output layer aligns with what you have in your data. Then it will then adjust that back through back propagation, and that process will continue until the error is very, very low, and that will give you the desired output, at least if you do everything right, because this is dependent on several things. You have the learning rate, you have the activation function. Depending on whatever setup you have, this will happen and give you the final output. So that is how deep learning works, basically. And you can specially use deep learning for example, large data set. As stated before, there are images used for image classification, so they can learn different patterns in the images. For example, cat and dog, or you are classifying crop diseases, or doing different kind of things that you're doing to your images. And you have the time series also. So deep learning can be used for time series forecasting. So you have like a recurrent neural network, for example, and you can give it previous data and it can learn from how those changes occur depending on the time interval you give to it, maybe monthly, daily, or yearly, and it can use that to forecast what will happen in the future. So this is used a lot in many areas. Then you have the text, so it can learn text sequences, and that is what gave birth to the natural language processing that we use today. The ChatGPT's deep learning helped to give birth to this. Then the examples, you have climate trend prediction, crop phenology modeling, greenhouse gas flux prediction, crop type mapping from satellite images, deforestation detection, flood mapping, weed detection using drone images, and several others that you can use deep learning for. It is just inexhaustive. So, and the common model, you have the regular artificial neural network, or what they call like the MLP. You have the recurrent neural networks, which, for example, an example of recurrent neural network which works in an advanced mode is the LSTM, and the GRU. You have the convolutional neural networks that work with images, and an example of a convolutional neural network is also the UNet. So now we come to natural language processing, and what natural language processing does is just works mainly with text data, but now the technology has advanced. It's not just about text alone, it also works with images and other file types. So we have multimodal NLPs that works with text, images, videos, other files, different kind of things that can be done today. So there's a lot of advancement. And this is how it works. You can see where NLP fits in. So everything we talk about with machine learning, we're talking about artificial intelligence at large. And you have the ML, and the deep learning is a subset of ML, and the application area of machine learning and deep learning is NLP. So you can apply them in natural language processing. So that is what we have here. Now, examples, you have chatbot for farmers. So you can use natural language processing to build chatbot for farmers. You can do simple diagnostic systems for farmers. You can use it to transform unstructured data from farmers. Then you can extract insight from agricultural reports. So sometimes farmers don't have the full information on what to do on their farms. Yes, they have empirical knowledge, but based on their actions previously, you may want to inform them about how they can take specific action. So with a chatbot, the farmer can just say, okay, this is what I have, this is what I'm seeing on my farmland. And based on that, the chatbot can then check and read through the farmer's input and then say, okay, based on this, do this. And the farmer can learn from that. And the common NLP task, you have the text classification, information extraction, topic modeling, question answering, which is what like this chatbot uses. So this kind of technology has advanced in a way that the farmer doesn't even need to say so much. They can just scan the issue on their field, maybe it's a disease or low yield and all sorts, and they can scan that, and the chatbot can learn. Of course, it's dependent on a specific model that has been trained to then give the farmer the output that the farmer wants. Also, the chatbot can help to speak to the farmer in the language the farmer understands. So it's not just English. So the farmer is in Uganda, the farmer is in Nigeria, the farmer is in Spain, anywhere in the world. NLPs can help us relate to farmers in a very clear way. This is where we are going to end this video today. And if you've benefited from this video, feel free to like it and subscribe also, and turn on the notification bell so that you can get notified when new videos are being uploaded. So thank you very much.